Today we're going to finish off Chapter 9. And remember, Chapter 9's title was Solving Equations. So we looked at all kinds of situations today. Sheldon, I'm going to have it marked by the end of today. That was my goal, was to have it done by the end of today. You're welcome. So the idea here is that we're trying to solve all kinds of equations. And one of the sore spots for students is equations involving polynomials, and specifically when you're solving power functions. So for example, here we have a power function, it's x to the n equals a number. Like for example, x squared equals 70. So sometimes you can have two answers, sometimes you have one answer, sometimes you have no answer. It depends on the value of a there, if a is positive or negative, and also if n is even or odd. To put it simply, there's a really nice table which you can find on page 20. I'll just show you it here. You don't have to copy this table down, obviously it's in the notes. But you can see how the table is dissecting the different cases. So we have, I'll just remind you about the equation. It's x, make it nice and bold there. Let's make a nice bold symbol there. When we have x to the n equals a. I guess people are on Blackboard today. A lot of people. It's very slow. Anyway, when n is even, it doesn't matter about the color. It's fine. Yeah, honestly, I don't know why it's glitching so much. And when n is odd, versus when the number a, whatever that value is positive, or when the value a is negative. You can organize all the questions in that way. So for example, if n is even and a is positive, you're going to get two answers. And here's an example, like x to the 4 equals 81. You'll end up with two answers. See, it has plus or minus 3 there. In this case down here, if a is negative, so if you had like x to the 4 is negative 81, then you're going to get no solutions. It's impossible to find a solution for that situation. There's also two cases to examine on the right. So on the right here, we have the two situations where the number on the exponent is odd. So you see x to the 3 here. So when the exponent is odd, you're always going to get one solution. Doesn't matter what happens, okay? Whenever it's odd exponent, you're always going to get one solution. Whether that number is positive or negative, it's really the number of solutions is insensitive to what the sign of a is, whatever that number a is. And that's pretty much it. So the thing here that we need to make sure you're okay with is how to do these things. See these roots here? Like, how do you do this? How do you do the fourth root? I think we played around with this earlier in the semester. How do you do the fourth root of x or something like that? So we'll practice those types of questions. There are several questions available on the next page. They're on page 21. You can see them in the side tab. I've selected, looks like I selected 8 of them. And we'll just go through all 8 of these questions. After that, there's a few questions on the last couple of pages involving geometry and measurements with shapes, and that's about it. So today's class is going to be pretty much mechanical in nature, nothing too dangerous to work through. So let's take a look at this first example. So you see the number 2 there, that the exponent is even. So when you have an even exponent, I won't write that down actually. I'll just mention that it's even, okay? When you have an even exponent, then you're going to get two answers. So x is going to equal plus or minus something. In this case, what would the answer be? What number would that equal? Plus or minus what? Any volunteers on that? Yeah, that's right. Thank you, Nicholas. It's plus or minus 5. Remember that whenever you want to get rid of an exponent, you want to find the root of the same order. So the next step usually looks like this. You put plus or minus because the exponent is even, and then you put down the root. Now, I'm going to write down the square root. You don't have to write the number 2 there. I'm putting the number 2 there because in general, what if the question was x to the 4? Then you would put the 4th root, okay? So I'm just patterning it for you. And of course, the root of 25 is a fairly easy number to do in your head. So that takes care of the first situation. In these examples that you see on the page, we're exploring all 4 cases. With the first 4 examples that I do with you, those 4 examples are related to the table that I just showed you with all the cases. So in this case, we have an even exponent, and the first one, it equaled a positive number. In the next case, we have an even exponent, but it equals a negative number. So we need to sort out how to deal with that. When it equals a negative number, then there's no solution. The reason is as follows. If I take a number and I square it, no matter what that number is, if I square it, the answer will never be negative. Pick a number. So someone type a number in the chat. Positive or negative, I don't care. Like here, 5. If I square that, that's 25. Negative 3. If I square that, that's 9. 0. If I square that, it's 0. No matter what number you give me, I guarantee you the answer when you square it will never be negative. So that's what this question is really saying. It's saying find a number that when you square it, you get a negative answer. And of course, that's a ridiculous situation because you can't do that. So now you might be like, well, can I do it on my calculator? I understand people want to see it on the calculator. Go ahead. Type in on your calculator the square root of negative 5, and you're going to get an error. You're going to get an error. In mathematics, there is an entire branch of math that's dedicated to the square root of negative numbers, but we're not doing any fancy stuff here. We're just doing some basic equations. Now, here are here's an exponent where the number 3 is odd. So we have an odd exponent, and it equals a positive number. Remember, when the exponent is odd, I don't care about what it equals. I don't care that it's equal to a positive or a negative. So these next 2 examples that you see, all that matters is that the exponent is odd. I don't care about categorizing if it's positive or negative. So in this case, to get rid of the 3, what's the opposite of cube? What's the opposite of cubing a number? Can someone let the class know in the chat? How do you neutralize a cube or a power of 3? Thank you, Nicholas. That's right, you do a cube root. Now, on your calculator, you can definitely locate that button. And yes, the answer is 4. If anybody in the chat here has difficulty finding a button on their calculator, just mention it in the chat. And when we get to the end of class, I'll stick around with those students and help them deal with their calculators. So this last example, which kind of covers all 4 cases, is another odd exponent. And yeah, it equals a negative, but you can take the cube root of a negative because you're looking for a number that multiplies by itself 3 times. And when you take a negative times a negative times a negative, you still get a negative. So in this case, sorry, I just scrolled there for a second. In this case, that would be acceptable because the exponent is odd. So the cube root of negative 64 is negative 4. So there's no issue there. So those are the 4 questions that cover the 4 possibilities that you saw in the table. Anything that I do after this point is just extra practice. So I've just chosen several questions. Let me see here. Well, 4 more questions, I should say. And we're just going to do these 4 questions and then move on to the next subsection on just some application questions. So x to the 4 equals 75. Before we answer the question, can someone let the class know how many solutions are there here? Are there 2 solutions, 1 solution, or no solutions? What do you think? What does the class think? It may be useful to look back at that table. I don't know how big I can get a table on the side here. Let's take a look. So we have an even exponent, and it equals a positive number. So that would indicate that there are 2 solutions. If you're not sure how to solve this question, the number 4 is even. So just pretend for a second that the number was a 2. If it's a 2, then you know you do plus or minus. So if it's a 4, just like with the 2, it's even, you still do plus or minus. The only issue here is how do you type that on your calculator? Because 75 is not a number for which the 4th root is easy to calculate in your head. You do need a calculator here or something more fancy. So what is the 4th root of 75? Oh, okay, yeah. Yeah, I'm just going to type it as well here. Anybody have an answer on that? That's right. Yeah, let's go with extra decimals here. Thank you. Thank you for that. Let's go with some extra decimals. So in this case, we have it says 4 significant digits. If you in the page 21 header, it says 4 significant digits. So thank you for that. Perfect. So there's your answer. If anybody had difficulty figuring out how to find that button on their calculator, I think I'm almost certain that we explored this button on the calculator because it was in an earlier chapter, if you recall. Very certain about that now. Okay, so let's go to question 14. I see Nicholas is stealing the show today, and I appreciate it. But someone give our friend here a little bit of a break, doing all the work for you. Is there anybody else in the universe here that wants to help answer question 14? What would be the first step in question 14? Nicholas, your answers are still welcome. We appreciate them. Thank you. What's the first step here? Thank you, Marco. Nicholas is the Connor McDavid of your class today. He's skating through the whole team and scoring the goals. But it's okay. Marco showed up now. Marco's the heavy defenseman. He's the one that nobody gets by. So anyway, we have x squared equals 40. So what I did there, I'll just so everybody's clear. What Marco says is divide both sides by 3, and that's how I got to that step. That's how we got to that step. Now, that's an even exponent. So we're going to do plus or minus square root. To 4 significant digits. I got, what did you get? 6 point something. That's right. Interestingly enough, thank you, Norris. Thank you very much. Interestingly enough, if anybody here is curious, how do you do square root of 40? I mean, that's not something that's easy to do in your head. But if anybody's curious about how to do that calculation in their head, I did make a video about that. I have a video about that on the channel there, and I'm working on another one that's pretty funny. But anyway, what are we gonna do with 17? 17 is reminiscent of what we did last class, where we had the x popping up on different terms. So we in the previous class, how did we deal with the multiple x's in the equation? What would be a good first step here? Any suggestions? Yeah, move things over. That's right. So let's get those x's on one side because they have the same variable part. You see how they both have x to the 4? They have the same variable part. So this is why we can collect them onto one side, and let's move all the numbers onto the other side. By the way, if this was x to the 4, and hypothetically, this guy over here was x to the 3, and this question would be beyond the scope of the course. We're just talking about simpler equations here and patterning various things. Norris, you have a question?
Yeah, I was supposed to ask this last class, but I forgot. How come when we move it over, the plus changes to a minus?
Okay, so the idea is that you're trying to neutralize something. Let me show you something from kind of like last class over here. Just something quick. You'll get it. You'll get it quickly here. 4x plus 3 equals 2x plus 7. I'm going to make this a minus 3. So this is just in reference to your question. Um, so the idea is that let's see this negative 3 here. You're going to move it over and it becomes plus 3. But really what's happening is that you're trying to neutralize the 3. So you're adding 3 to this side and you're adding 3 to that side. And then what happens is that by adding 3 to both sides, you're preserving the equation. You're not wrecking the equation because you're doing the same thing to both sides. But these guys neutralize each other. And then you just end up with the 3 on the other side. So it is the illusion that you're moving it over and it changes sides. It's just an illusion. It's like a magic trick because you're just the pattern that you observe. Same thing here. I can subtract 2 from both sides because that would help me neutralize this 2x. But it has the illusion that this 2x sort of moved to the other side and became negative. Does that help?
Yeah, I see. So say if it was like a multiple, I mean, like a division and multiplication question. Would
Uh-huh.
I still would I still like neutralize it, or would I do
Yeah,
like?
with division and multiplication, you would still be, your goal is always to neutralize something, but with division and multiplication, you won't see any signs switch. You'll only see the number change, but it won't change signs. There's only two cases, okay? Here's the first case. 4x equals 12. On the next line, I would divide both sides by 4. But you notice that I'm not changing any signs because these 4 divided by 4 is 1, 12 over 4 is 3. Nothing changed signs.
Yeah,
You get x equals 3. Now I'm deleting them here, but I'm recording the lesson, so you can go back and look at the same argument later.
yeah,
Um,
yeah. No, I get it.
and then the last one here, some fraction stuff here, okay? Like 1/5 of x equals 2, 3, 2, whatever. You want to get rid of the 1/5, and to do that, you would multiply by 5. So here I'm going to multiply both sides by 5 to neutralize that fraction and get x equals 10. But notice that no signs changed. The only time that you see a plus or minus situation in terms of moving things around or neutralizing, I should say, is when it's a subtraction or an addition.
Okay.
Okay, back to business, I guess. Are you okay?
Oh yeah, yeah, yeah. No, I got it. Thank you.
Okay, you're welcome. All right, so in this question here, we managed to collect all the terms to one side. Now the next step would be to neutralize that 5. That's no different than this question. So remember Marco here said divide both sides by 3. Well, here, let's just divide both sides by 5 because that would get rid of the coefficient. Dividing by 5 is not a difficult task. There's shortcuts for that as well. Well, you know, all these things with shortcuts with arithmetic, you can you can find them on most like anywhere on the internet. If you just Google like, you know, shortcut for dividing by 5, you don't need to like do any fancy reading for that. But anyway, I divided by 5 there. And now that number 320 is not a perfect it's not going to be a nice answer. It's going to be something with decimals. Or in this case, what would the answer be? What do you think the answer would be? Have some of you tried this on your calculator? What did you observe on your calculator when you tried this? Or what do you think the answer is? What do you think the answer is to this question? That's right. It's undefined error. We're going to go with the phrase no solution. It's exactly this, everybody. It's an even exponent equals a negative number. I'll put a star here, and then I'll just put a star here so that you know I'm referring to that example. That's why it's so important to have that table, like in, not the table, just 4 examples. No solution. Okay, one more question. I mean, we're not going to drag this on more than you need to. There's lots of nice questions on page 21. I didn't skip the hard ones and give you all the easy ones. I just tried them all. You know, I'll probably pick one for your assignment from there anyway and just change the numbers. That's usually what I do for some of the more mechanical questions anyway. Well, this will be our last question from this information here. So let's see what we do with it. I just want to make sure I copy the question right. Okay, so I'm just double checking something that it is going to work out well. This question looks very dangerous when you first kind of when you first try to make an attempt at it. You kind of might get scared, and even I looked at it for a second. I said, "Does this question belong in this course?" Because I was worried that not all the x's would cancel in a way that it would be favorable to us. But actually, it's going to work out quite well actually. So we're going to do this distributive step here, x times those guys, and then we're going to do 1 times these guys down here. So that's going to involve a little bit of typing. And for you, a little bit of hand exercise, scribbling some stuff down. Here we go. X to the 3 plus 6x plus x to the 2 plus 6. So that's the left side. On the right side, we have x plus 3 all squared. We've actually seen this pattern last class. So because we saw this last class, I can virtually repeat that process. And hopefully things work out nicely. So anyway, I'm just going to unfortunately, you have to write more than I do because I'm copying and pasting here all the time. But if you just copy that down there, then you can distribute these 2 brackets out as well. So what I'm going to do is a second binomial step here. So this binomial, whoops, this binomial times that binomial. Okay, so when you expand that out here, you get x squared plus 3x plus 3x plus 9. Just keep on widening the box here. Okay. Anyway, now we can collect like terms. Anybody notice anything that's obvious that's going to cancel? Anything obvious cancels? Let me know in the chat. What's the same on both sides? Any terms that are the exact same? What do both sides have that's the same? Thank you, Matthew. So the x squareds cancel. And yes, Norris, the 3x's are going to go away shortly. You notice that we have on the left side a 6x, and on the right side we have a 3x. 3x plus 3x is equal to 6x, so those cancel as well. So I'll just underline those, because those guys are equal to each other. You can just cross that whole thing out. So the blue stuff's gone, the green stuff's gone. What the heck's left over? So we have here x to the 3 plus 6. 9 minus 11 is -2. X to the 3 is equal to, move the 6 over, and you get -8. So we're almost there. We're almost there, everybody. To get rid of a cube, you're going to take a cubed root to neutralize that. And yes, whenever you have an odd exponent, I don't care what's on the other side. If the exponent is odd, you always have a unique solution, which in this case is a very nice number. It's just -2. So you see, these questions have a mixture of mental math and calculator math and a little bit of algebra to spice it up a little bit. Anyway, I hope that this, for the most part, what would be a review of powers and solving power equations was something fruitful for you. We're going to spend about 20 minutes or so doing some questions and applications. If it finishes less than 20 minutes, then you can dedicate the rest of your time to the assignment, which is due today, or you can start prepping for your quiz for your other course, which is totally cool. So I'll just wait for 30 seconds, and then we'll move on to the next examples. For those that are curious what we're doing next, in the margin here, just a second, Matthew. For those that are curious, there are 3 questions on 22. We're gonna try at least 2 of them right now. Now, your question about the assignment. My hint to you is this. At the end of, I'm gonna type it in the chat, okay? So let's just do 2 more questions here involving 3-dimensional shapes, and then that'll be it for today. So the first shape here is a rectangular prism, and it says what length, L, in feet of an air duct that is 8 inches by 10 inches in cross section will have a total volume contained, which is 200 cubic feet. So I don't necessarily see the presence of us doing any square roots or anything weird like that, but still we're just in the realm of solving equations. So this question fits in nicely. Plus, I like to throw in as many questions that are practical as possible. So what we want to do is solve the volume equation. So the volume is equal to length with height. I'll use an uppercase L because the lowercase l looks like a 1 when you type it sometimes. So the volume is 200 cubic feet. So let's put 200 cubic feet. A very sound piece of advice, guys. Whenever you're doing these questions, please put down the units. Not for me. I don't care if you write the units on the intermediate steps, but for you. Because when you write this down, yeah, L is just a variable, but W and H are going to be 10 and 8, or 8 and 10. Doesn't matter which way you say it. So 10 inches and 8 inches. And it just emphasizes to you that you need to figure out how to rectify that. So I think the safest play here is to go with feet, because the question is asking for L in feet. So you might as well go with feet. If you don't want to do that, you can convert at the end. But I'll do it immediately, but it is kind of cool if you do the conversion at the end. I might show you the other way that I'm thinking once we solve the question, because I think it's really cool what I'm going to show you. So anyway, first let's go to feet here. So if you convert to feet, you would divide by 12. And then over here, you would divide by 12. Notice that I didn't type that on my calculator because I want to defer any like rounding issues until the end. I'm just showing you it one way to solve it anyway. Let's take all this and multiply it out. So that's 80. I'll do decimals now. 80 divided by 144. Oh, that's a funny number. So we get 0.555 repeating square feet. I've rounded it, so I'll put an approx symbol there. And then divide both sides by that number. So if you divide cubic feet by square feet, you get linear feet. So 200 divided by answer on my calculator is 360. So that's the way that would be good to solve it. Some of you would prefer to convert the width and the height immediately in the question. That's totally cool. I think that's a great way to do it as well. Let me show you what I was thinking about, which is weird, okay? Don't do it this way, but just let's experiment. Okay, we're just going to experiment for a second, okay? So I'm just experimenting. I want you to see something different. See what you think about this, okay? Now, see, you might wonder, because you obviously, I'm here teaching you means that have some good experience with math and physics and all that. One of the things that made me more successful in school, especially with this kind of stuff, and in career-wise, I mean, um, is once I had the answer that was correct, I thought about how I could solve it different ways. So that's what I want to do here. I just want to have some fun with you and maybe try solving it a different way. So let's try an alternative way. Again, what I'm going to show you here might be really annoying to some people, but perhaps it gives you insight into how to approach the question differently. Because what I'm writing here is totally cool. This is acceptable. You might say, but John, oh, it's feet and inches. It's going to get screwed up. Don't worry. What I'm doing here is just kind of passing the buck along until the end. So I'm kind of like procrastinating about the unit conversion. So we have that. That is actually a legit step. That is actually mathematically correct. But what we want to do now is convert to feet, not inches. So what I'll do here is I'll multiply by 12 inches over 1 foot. And I'll do it twice, or I could square it, but I'll just do it twice because it's faster to copy and paste. And you're going to get 360. So this is the step that I'm just kind of doing weird. And I know that's going to annoy some people the way I did it, but maybe it inspires you to see it differently. You see all the feets cancel, and then we just get feet. Isn't that cool? Who likes what I just did there? Who actually liked that? Not for their personal use, not for how they're going to do their math in the future, but who appreciated that kind of step, like doing it differently like that, seeing how it works out regardless. See, and you don't have to do it that way. Thank you, Marco, and thank you, Norris. You don't have. I'm not telling you to solve questions this way. I would solve a question the way that you would solve the question. Play it safe. Make all the units consistent. What all I'm saying here is, if you're the kind of person that's like, let me go through the calculations and deal with the units later, you could actually still do it, but you might get a little bit of a headache. Anyway, we're skipping the 2D question, and we'll move on to this question here involving a silo. So I'll just zoom in a little bit here, and hopefully this question involves a root of some sort, because I'm kind of irritated that the previous question didn't have a root in it, and we were doing roots all the time today. So anyway, hopefully this one has a root in it. So we have the walls of a silo form a cylinder. That's great. And then there's a cone on top. Okay. So it says, what is the radius of the cylinder and the cone so that the total volume is 10,000 cubic feet? This is a glorious question because it combines volumes question, it combines the stuff we did at the early part of today's class with square roots, and it has some algebra in there. So this question is pretty awesome. I like this question so much. I'll pretty much tell you. I'm gonna give you a question like this on your assignment. I like this kind of question, so look for it on the assignment this week. I promise you this question, okay? Different numbers, obviously. And you can, of course, look back at the notes or the video or whatever and double check. So anyway, the total volume will equal 10,000 cubic feet. So I'm just going to make a note here. This is a minor thing, but I'm going to say that all dimensions are in feet. It's just a mental check for myself that everything's cool, okay? So once I see that all the dimensions are in feet, I'm a happy guy. I don't worry about like what I did in the previous question with the inches and all that stuff. So what we have here is that the volume of the cylinder plus the volume of the cone is going to equal 10,000. Now, it's 10,000 feet cubed, but I'm not going to write down the units. So the formulas are given for those, so that's awesome. Let's do that over here. So we have here pi r squared h plus a third pi r squared h. If you didn't know this already, cylinders and cones have very similar formulas for volumes. Now we have to be careful here because the cylinder and the cone do have the same radius, because you see how they're adjoined here? They do have the same radius, but they do not have the same height. So we need to differentiate their height. So you don't have to put the whole word cylinder or cone here, but it's convenient for me to type it anyway. So let's toss in all the numbers that we know, and hopefully we get something meaningful. In other words, an equation involving a single variable. So we have pi, radius squared, which don't know the radius. The height of the cylinder is 30. I'm just reading it off the picture. Plus a third pi r squared again, and the cone is only 10, and that equals 10,000. So I will scroll down here because we don't need the question anymore. The question is basically an algebraic one now. Now, you might get scared because you see the pi here. You see the pi everywhere here. You might get annoyed. You also see the fraction here. That might annoy you as well. So what I would do is I would actually just bring the numbers together first on the left side. So I would write, I'm going to just rewrite this a little bit better as 30 pi r squared plus 10 over 3 pi r squared is 10,000. You could turn this all into decimals at this point. So if anybody here wants to just make everything a decimal, be my guest. I'll do the same, but I encourage those that don't want to use decimals until the end, try to solve it as an exact answer. So let me do it both ways. First, I'll do it with decimals, and then I'll do it exactly so that both people are satisfied. So 30 pi, I'll use lots of decimals here because we want, in the question, I think it's 3 significant figures, 94.248 r squared, and then 10 pi over 3 is 10.472. So we're in a position now where it looks like one of the earlier questions. If I scroll back here, now you see decimals, you might get kind of distracted by the decimals. But take a look at this example on the left here, and this one here that we did earlier is very similar. You're just going to divide both sides by that 104. We get r squared. Oops, r squared equals 100 or 10,000 divided by 104 point whatever that is. So if I do 10,000 divided by that, 95,493 And then here you get r equals plus or minus. We'll talk about that in a second. All right. Any comments about this answer? Any thoughts about this plus or minus business? What do you think about this plus or minus business? Is that, can you have plus or minus here? What are your thoughts? It's so quiet. I guess people have starting to check out. They got their quiz on the way. You should always reject the negative when you have a length, because R represents a length. So the final answer is 9.77 feet. I guess people are kind of either chugging along with the algebra, or they're a little bit worried about their stuff that they have to deal with in the afternoon. Anyway, I'll show you how to do it the other way with the exact answer, like how to find the exact answer right now. But this is not for a quiz or anything. So I'll do that on the next page. I'm just copying the same question, but I'm going to do the exact answer this time. So if we go back here, what you can do is multiply all sides by 3. What I'm doing here is, let's find the exact answer this time. So if we multiply everybody by 3, we get that. In some ways, multiplying everybody by 3 and finding the exact answer is actually faster. We can even divide everybody by 10, but I'm not going to do that yet. We'll be done this in about 2 minutes, guys, okay? Now you want to get rid of the 100 pi. Divide by 100 pi. And you get 30,000 divided by 100 pi. I'm not going to take the plus or minus, okay? Keep only the positive root. So then R equals, oh, and you can reduce this as well. Let's reduce that here. So that'll be 300 over pi. So final answer, the exact answer would be 300 over pi. And I'm just going to grab my calculator and confirm that it's going to be the same answer. Unless, can someone check that 300 over pi square root is the same answer? I'm doing it as well right now. And don't forget your units. Anyway, guys, that's enough for today. We'll do another chapter next week involving formulas. So I hope you have a lovely weekend, and I'll have those tests marked for you by the end of today.